Hello, John Green here with BlueLab Meters, and welcome to today's program, Can We Grow More Food with Less Resources? A little bit about BlueLab. BlueLab Meters are, I feel, one of the best and probably one of the most respected meter in the hydroponic industry. We carry meters from handheld pens to handheld meters with replaceable probes to monitoring systems to full dosing systems such as our pH controller, which can dose up or down, to our flagship, the Pro Controller, which can not only keep your pH perfect, but can distribute all the nutrients for a perfectly set up reservoir. Sorry about that. Anyway, I like the opportunity here to say that I love working with what I call our partners, the cultivators and the operators and teams here at BlueLab, to measure, monitor, and control the fundamental parameters like EC, pH, and temperature. Our team is into educating the indoor controlled environment agriculture, all the way from the hobbyist up to maybe a greenhouse grower, backyard grower, to a small facility, all the way up to a commercial facility. The reason we have these webinars is to tackle some of the questions that are out there. So not only to educate you, but to also let you have the opportunity to ask some questions to some of our educated panelists here, like JC, because we all have the same vision in mind, and that's growing for a healthier world. Today's program is called Can We Grow More Food with Less Resources? I'm going to go ahead and give you let you know the housekeeping items right now. We will be recording today's session, and all attendees will be receiving a link to the recording along with some helpful resources from our panelist, JC. I also want to remind you to go to the webinar tray on the right-hand side of your screen to check your audio settings. You may need to adjust your speaker or headphone settings if you're coming to us through a computer. Look at the audio tab. We also have allocated time at the end of our program today for Q&A, so please use the question pane at any time if you have a question for JC. A little bit about myself. I came from the tree care industry where I spent over 40 years and working with and owning a company that did tree work as far as tree trimming, planting, removal. I also worked as a certified arborist, taking CEUs and educating in tree physiology, as well as going into IPM. So it is basically spoon feeding the plants. So you've created an artificial environment for them, and that took a little while to understand. So I have a pleasure of introducing you to Joseph Chidiak, who's also known as JC. And JC and I go back a ways, so I like to say that we go back to the nights we used to run the streets of Brooklyn, stealing hubcaps, drinking beer, chasing girls, but that's not true. We actually met in Denver, Colorado, and we met about 4 or 5 years ago at a small hydroponic store in Denver, Colorado called Culture Garden. At the Culture Garden was kind of a boutique, a very boutique store, in that it also was a garden center, but it not only had all the hydroponics wants and needs for the grower, it had a very nice setup as far as garden equipment went as well. But boutique also that it had a staff there of a young man, JC, with some very innovative and cutting edge ideas. And so with that, I'd like to introduce JC to our webinar. Thank you for showing up today.
Thank you very much, John. I'm glad to be here discussing this interesting topic with you.
Very good. So I'd like to start off really quickly with, I noticed that, well, you are the founder and owner of Cultibio, but you also label yourself as a horticultural engineer. And can you go back and give us a little bit of background on that, please?
Sure thing. First of all, there was no term to really accurately describe what I wanted to do for a living. So we came up with horticultural engineer because it simply means problem solving in the world of high value crops. Now, I do have an engineering degree and then finished up with a master's in horticulture. And since then, I've just been specializing in bridging the gaps and finding solutions to the problems that growers face when they're growing high value crops in different parts of the world.
Okay, good. That's good. Yeah, I'm sure there's people out there that are probably thinking that that's something they would like to do and get into, but like you said, it's something that you've actually kind of put together. Great. Let's go ahead and start off with the Ozark All Seasons. And you'd like to give us a little bit of background on that?
Sure. Well, that is a wonderful little farm in northwest Arkansas. And it was also the location of my first internship in horticulture or hydroponics, basically. Ended up becoming good friends with the wonderful owners. And Dr. Ahlens is now one of my mentors. So I've definitely learned a lot from him. I'm happy to say that finally coming around to make a few small contributions of my own and get involved in some of the interesting work that he's been doing, pick up the torch and carry on a little bit. So first thing that Dr. Ahlens and his wife, his partner, did over here is build very low carbon footprint greenhouses. Aside from wanting low bills, they felt that this is the conscientious way to approach this type of problem. So they built greenhouses that are extremely efficient. They invested extra funds in making it so that they can use geothermal heating and thermodynamics, and there's a lot of insulation in here, just high quality materials that make sure that it performs well with low inputs. Then they went ahead and bought one of the country's leading hydroponic systems and started growing lettuce for the region. In so doing, they're actually displacing several tons of fresh produce a year that typically come from California in terms of greens and Arizona. So they're definitely a boon to the community over there. They've been the largest farm of its kind in the area there. There have been others that have tried and failed and a few more that are coming up. But basically, it's just an essential effort that does need to grow, and they've demonstrated that it can be successful and profitable. Now,
Very good.
John, they are moving into some frontier crops. So as they've kind of perfected this model they have, they're looking at what can be grown in hydroponics that is not typically grown in hydroponics. Is that the next point you were going to get to?
That's exactly where I was headed. So if you want to go ahead and touch base on that, let the audience know about what we're growing now and what frontier products or agriculture is.
Sure. So first of all, when it comes to controlled environment agriculture, controlling environments costs money. Obviously, there's a lot of different ways to do it, at different levels of expense, but you only spend that money if it's worth it. In other words, if your product is valuable enough to actually absorb that cost and allow you to still make money off of it. So naturally, what has really dominated that industry is a lot of these fresh and perishable greens and microgreens and delicate little vegetables that have high nutrition value and that really don't travel well, things like that. So they've been the first ones that had a high incentive to grow them locally and regionally. And obviously, many of you have also seen greenhouses full of things like tomatoes and peppers and cucumbers, primarily in Europe because they have more land constrictions, but increasingly so in the United States with companies like App Harvest growing acres and acres of tomatoes undercover. So when we talk about frontier crops, it's breaking out of some of these traditional foods that we commonly grow and we commonly eat and are commonly found in our country, but they usually come from a central location. So it's already lent itself to the decentralization of some of those crops. But now what's happening is it's actually affecting the global trade and transport of foods. So we're starting to look at things like the tropical fruits imported to Europe from the tropics. People are starting to grow those in Europe and vice versa. A lot of the cold weather crops that traditionally come from Europe and go to the equatorial world, farms are popping up to produce those regionally as well. And in the end, the main effect is that you're reducing food miles. So you're reducing the need for a lot of this bulk produce to be transported that far. And I think that's very positive. So maybe I should list some examples, John. What do you think?
Yeah, I think that's a great idea. Also, too, you hit something that I'd like to talk a little bit about too, is just the carbon footprint. You started to go on that, so maybe after that you can kind of go into the distances and what it does to the environment. All right?
Sure. Yeah. Let's just touch on some interesting examples. So the first one are these greens that are increasingly grown in different places that mainly come from California and Arizona. So any farm that pops up anywhere else in the US or Canada for that matter is actually reducing the need for transport and reducing the greenhouse gases that go along with it. In Holland and Iceland, I've seen greenhouses growing bananas. Some of this is still experimental, but some of it is definitely at the commercial level. You cut out the transport costs, so you can easily be more competitive, even though you might have higher labor costs and energy and things like this. But there's some smart schemes people are using with cogeneration and taking advantage of steam where it's available and things like that. I saw another project where they're growing papayas in Europe as well. And we're working on a lot of projects that are doing things like spinach and arugula and cilantro, cold weather crops in the Caribbean and things like this. In China, you're starting to see a whole lot of these orchards, and in Europe, to be frank, starting to get covered as well, going from traditional orchard to controlled environments for various reasons. Things like apples and almonds and cherries and things like that you know, are susceptible to a lot of diseases that require a lot of pesticides and fungicides. By putting them in varying forms of a box, you can eliminate the need for all of those inputs in a lot of cases, and your biocontrols, if you're using those, can be kind of kept in its place and rendered more efficient. So that's some of what's going on there, and it's just going to continue that way. You're going to see root crops start to increase in price to the point where they're viable to be produced here. And in this photo that you guys are looking at right now, it's Ozark All Seasons experimenting with some things like dwarf apples, gojis, and wasabi. And what you're looking at in the picture is actually broccoli and cabbage. And it turns out these things grow very well in hydroponics. They just take a little bit more space than they're worth currently in most markets. But figuring out how to do it is the first step, because inevitably it's going to come to the point where they're worth the space and the effort.
Right, and I think you and I had touched base and talked about, I think it was saffron or ginseng that you were saying that was something that's on the horizon. But what do you see as a stumbling block? What's going to be that particular crop that you feel is going to be a hard one to get over?
Oh, you're right. Yeah, saffron is starting to get a little bit more prevalent in CEA, as are many of the berries. Stumbling blocks have to do with economics, more or less. So I'm in the business of overcoming the technical challenges here. And oftentimes, John, those are not the biggest challenges. You know what I mean? So taking a systematic approach to actually solving the issue of how to effectively build an environment that can perform in plant production is different than making sure that there's a market that will accept your prices and your quantities and things like this. So it has to do with education more than anything, I think. Just a few decades ago, the majority of people in the US, for example, and possibly around the world, had this feeling that hydroponics was not natural because it was novel, and people have a fear of the unknown. So a lot of people resisted it, and you heard strange claims from people who I don't think really had any experience say, oh, the tomatoes taste like water and the lettuce is garbage, and they had their reasons for saying this, but at this point, many people have had a chance to experience it for themselves. They've spoken with the farmers. They know it's clean. They know it's local. They know it's fresh. And it does taste extremely good. Here you've got some tomatoes and sugar snap peas that these guys are looking at in the photo there. And those sugar snap peas were the best I'd ever had. I've grown them in pots of, you know, perfect organic soil and things. So the awareness is coming. And it also increases people's interest in getting involved, which is the whole point. Because you're supposed to be proactive in your food production, not just rely on farmers. We need more farmers operating smaller farms. We need them to have tighter relationships with the consumer, and the consumer should participate too, especially with the things that they can afford to grow in terms of time, space, and energy.
Right. Well, you said something about the popularity of it and it's catching on. I mean, if you go back historically, the Hanging Gardens of Babylon, the Aztecs' floating gardens, the Chinese, the Egyptians, I mean, they all dabbled in hydroponics. So it's nothing relatively new. So what are some of the stumbling blocks now that people are having such a hard time with? Or, I mean, it's been around quite a while. What do you see that is a stumbling block? I mean, we know the benefits of it. Can you go over some of that?
Yeah, so that's a good question. First of all of the ancient hydroponics was really just in the form of pure and unmanaged aquaponics. That always was the source. And we're kind of coming full circle here, and we'll talk about that most likely. But the challenges are that now hydroponics takes a lot of interesting forms We're using very effective water-soluble fertilizers and things like this. It's not entirely sustainable, but it is a very good value proposition when you talk about the water savings and everything like that. The challenge is usually information. So a lot of this information, as you're well aware, that people seek comes from either unqualified sources online that just decided to write a blog, and the rest comes from technical salespeople whose job it is to know about what they sell, and that's really all they can explain to you. So people get the feeling that there's not a whole lot of choice out there, when that is never the case. There's always many, many options, and that is its own confusing thing because it becomes hard to sort through all of these potential options and information. So basically, there's no wrong way and right way to do things, but there's more effective, more efficient ways to do things. And so the good research that I see that, including Dr. Aylens here, is trying to tease out what fits where best. You can do anything with anything, just not as well as you can with the right thing. So there's multiple hydroponic methods available to us. They each suit certain crop groups better. And we'll continue to kind of elucidate on that fact. There's also new and kind of hybrid methods that we're in the middle of developing that build off of the advantages of these conventional systems, mainly NFT and DFT that have been conventional for a while now, and then tackle the disadvantages, the faults that have been clearly elucidated at this point of several decades of commercial use. So we're trying to make this foolproof. Wanting to get everybody involved means trying to make it accessible, affordable, foolproof. We want people to have success the first time, and that takes baby steps, making sure that you're informed before you just dive in and spend your money and have a bad experience. We don't want that.
Yes. There basically is, I think there's about 7 types of hydroponic growing. So do you see anything in the future that maybe is cutting edge that might be going over that? Is there anything new out there that you work with?
I think fogponics is quite interesting, and it's not quite viable just yet, but that is just a technical issue. And so as soon as certain components are perfected for that application, you might start to see a lot more of that. And then instead of pumping water through a system, you're actually pumping air, which takes, water vapor. It takes less energy and is also, clearly maximally aerated. So you don't have to worry about dissolved oxygen like you do in other systems, obviously. Mm-hmm. So I think that's an interesting frontier and is likely what will end up being used in space applications and things like that. But when it comes to the farmer on Earth who really just cares about the bottom line, we're trying to simplify things, bring them down to the leanest of brass tacks. And I'll tell you more about that when we move on.
Okay, sounds good. Yeah, so do you, in your travels, do you deal much with aquaponics? Is aquaponics part of which you represent?
It's not one of my specialties, no. People ask me questions on it, and I tell them what I know, and I tell them where they can learn more. But it's essentially hydroponics plus bioreactor plus aquaculture. So there's 3 components there, and there's very few people in the world who are actual experts on all 3. And there's also, you can count them on one hand, the aquaponic farms in the world operating decoupled systems correctly and getting results that match optimized hydroponic production in greenhouses.
Absolutely. Yeah, absolutely. No, you're right, though, when you said you asked one person to get a different answer. You could ask 10 people and get 10 different answers. And it's in our travels at BlueLab, when we go into a facility, we find the same thing. That's everybody has their own style, their own way of doing things. Doesn't necessarily mean that person's right or wrong. Everybody has their own way of doing it. So since once you left the Arkansas area, where were your travels headed to next?
Well, that actually happened several times.
Oh, did? Okay.
You mean the first time or this last time?
Go ahead and start wherever you want.
Well, the first time was before we met you in Colorado there. But then we ended up moving back to Arkansas after that and have since moved to the beautiful little island of Barbados. It makes a good base for our activities in the region here. There's quite a multitude of projects that are related and similar with some of the same investment groups and others in the Caribbean. So we're down here enjoying the sun and sand.
I'd love to. So obviously the Barbados people, they pretty much have to import just about everything, right? So this is a beautiful, perfect fit for them. So can you go over a little bit about the controlled environments on the island there?
Yeah, so the audience, currently you guys are all looking at this greenhouse in front of you, and that is definitely worth mentioning. So this comes from a company called Sprung Structures in Alberta, Canada. And they've been in business for over 100 years. They strive for excellence in these rapid deployment structures that are very, very modular and flexible. So they make things for the US Army, they made the Tesla factory and SpaceX, and it's really interesting. So we've been working with them to customize a hurricane-resistant greenhouse. It can withstand 200-mile-an-hour winds, category 5, right? And make it so that it can perform in growing these cool weather crops that are imported in such an environment. So that's what we're working on currently. And this is all based on a previous project which didn't have access to this structure, but was primarily concerned with the system inside. So that story starts before me, obviously, but I picked it up as my master's thesis. My boss wanted me to work on using ebb and flow benching that is very common in the nursery industry, nursery plant production, and see how it could be easily adapted to a hydroponic system. So this was Dr. Michael Evans' idea. And we were using aggregate at the time, and we quite easily proved that it could meet or exceed the performance of deep flow technique and nutrient flow technique in a greenhouse under the same conditions with butterhead lettuce. And that was my master's thesis. So that told me that it was promising and worth pursuing further. Now, other students have done other studies on that with basil and things like this. And Tracy, if you'd like to move to the next photo, we'll see this system here, basically. It's just the ebb and flow benching on rolling benches that you can maximize space usage efficiency in a greenhouse. And there's no water sitting in it. It's basically, it floods and drains to about ½ an inch. And now it has plates or rafts on it. And so instead of shallow aggregate ebb and flow the way it started, it's now shallow aero ebb and flow. And it's a very simple method that has continued to work amazingly well, especially under the conditions where other existing hydroponic farms are struggling. So I think that's something I want to touch on real quick, is the fact that when we got to Aruba here, we're looking at local pride farms right now, there were at least 4 other hydroponic farms growing the same crops. And number one, they were unable to meet projections of what the sales folk told them they would get, because those people, meaning well, were accustomed to the performance in California and Canada and things like this, so they kind of missed the mark on tropical environments. And then they also don't even come close to meeting the demand for these things. So imports continue. So before doing any of these projects, we went and visited all of them, interviewed them at length at what their challenges were, what they were dealing with, and made sure that we had a strategy to mitigate every single one of those things. And that required a custom approach. And that's what we did. So this farm has been operating for 2.5 years now and is ready to expand by 10-fold and continue to grow herbs and greens and things like this until it gets to the point where there's no more imports of these for resorts and supermarkets and restaurants. And we're doing the same thing in Barbados, and we'll follow that up in Belize and Puerto Rico and Trinidad and Tobago, and there's quite a long list. And it's all about the fact that we are checking all the boxes. We're making sure that this is adaptable, versatile, effective, efficient, ergonomic, everything you can think of. And I'm happy to answer questions about this to people who are specifically interested later.
Okay, very good. Now, I'm sure this has helped the economy there as well, right?
That is the main point, yes, because there's
Right.
foreign exchange pressure.
Now, you were saying that it's going to grow by 10-fold here. So are they going to grow enough to suffice the island, or will they be able to export, or where do you see it going from there?
So the end game is to absolutely saturate the demand for these things, show that they don't need to be imported, show that the quality and shelf life is actually better when they're not imported, match the price, so it makes it easy for people to adopt it. And then the early adopters, these islands that kind of take off before the rest, can export regionally. So again, these products in particular shouldn't really travel far. But Aruba can definitely send it to Curacao and Bonaire if they haven't gotten with the program yet. Barbados can definitely send it to the Grenadines from over here in St. Lucia and things like that. So there's an opportunity for some regional trade there. But talking about frontier crops, we're already in the plans for berry farms. things like strawberries and blackberries and blueberries and raspberries that, again, would not go terribly well if you grew them outside here. And we don't want to use a lot of plant protection products, so we put them in our box, excluding all the pests, excluding all the pathogens, and basically keeping them clean and using a little bit of biocontrols. And those, a lot of them will actually go to value-added products, frozen berries and shake mixes and things like this. Same thing with tomatoes and peppers, they can go into sauces and things like that. That's where you have the potential to actually send them farther. That's where these products can start to go to the US and UK and kind of really tip the scales a little bit.
Very nice. Now, what we're seeing here on this picture, how much of this is automated?
So it's kind of minimally automated, John. In the Caribbean, we don't aim to eliminate any labor. Labor costs are not high.
Got it.
And unemployment is high. So we do want to create jobs. So basically, it's just the irrigation here that is automated on a timer. And aside from that, what you're looking at right here is a very low-tech farm. It was a pilot, and I think it's proved its point. So now we're putting a much bigger investment into it. In Barbados and the rest of the projects that are coming after, we're partnering with a company called Microclimates. And these guys have done a great job integrating a lot of the sensing and automation that we need for us and giving us a really nice intuitive software package. So then there's also dosing is automated, as you would imagine here, of nutrients. Nice. So we're going to have a lot of sensors and actuators in the greenhouse that all communicate with a little computer in the vestibule so that you can correlate the results you're seeing with the environmental data and see what changes you made and what effects they had, and make sure that you're always learning and your farm performance is getting better over time.
Right. How many people does it take to run a facility like this?
So the one we're looking at right here is about 5,000 square feet. That's typical size of a pilot for something like this. It seems to be what people are willing to invest in. And there's our head grower, Ashley Crozenbeek in this case, and he has one full-time assistant who works at the farm. Her name is Maria, and she's from Colombia. And I got to talk to her, and she was just so enthusiastic about all of this. She's in her 40s. She said she's been doing agriculture for 25 years. It usually breaks her back. And she doesn't have to bend over for this job. She doesn't have to get on her knees.
That's great.
She loves it, and she's still in her field. So basically, 2 or 3 people can handle that size of greenhouse full of greens.
Wow, that's nice. That's really nice. And it looked like they were using some type of a cooling wall. Is that what they're using over there to keep the temperature?
No, that's a good point. In the Caribbean, it's not wise to use head and fan evaporative cooling, really, because first of all, that only works at all if your greenhouse is sealed, closed, which means not ventilated from the top. And then it also creates a gradient, but that's neither here nor there. The problem is generally high ambient relative humidity already. And raising it any further kind of creates high susceptibility to disease and things like that, and it's not very effective. So instead, these projects rely on 2 things. Natural aspiration. In this case, you have a passive tropical style greenhouse that is designed to allow hot air to escape through the ridge. And then it has a slanted, screened vent so that rainwater doesn't get in, insects don't get in. And the greenhouse we showed you before, it actually has exhaust turbines that very quickly and actively suck the hot air out rapidly. So you end up kind of mitigating the greenhouse effect. Everybody knows what the greenhouse effect is. And when you take the hottest air out rapidly enough, it ends up being pretty similar to outside. Now, outside is still normally too hot for these crops. So then the second thing is our system allows us to effectively and efficiently cool the nutrient solution. So first of all, we don't have any water loss that isn't productive because there's no interaction between the air and the water. There's very little surface area exposed, if any. And then it's also insulated with these polystyrene rafts and trays. And so you use very little energy compared to the other systems in the same location that try the same approach. They use 10 times more chilling power than we do. And when you chill it to just the right level, your plants have an enhanced ability to cool themselves. So they start to grow as if the ambient air is not as hot as it is. And it saves us a lot of energy compared to trying to actually air condition all of that. We wouldn't make money on the produce if we did, John.
So in your travels, you have to take all this into account. I mean, you have to design something, whether it's in the tropics or it could be another environment too. So that's part of your challenge as well, right?
Every new place is a new challenge. So I want the audience to know that horticulture is incredibly site-specific. Before anybody can help you with anything, they need to ask a lot of questions. So when I get a new project in a new place, my hands are tied until I learn a bunch of things about that place, and preferably go there and talk to people about just exactly what it's like. Online research can sometimes be deceiving, so you really want to get hands-on, find out what people have to deal with, and what are the reasons why an approach designed for somewhere else would fail or fail to perform. And then make sure that you're conscientious enough to give the clients what they really need to run their business and expand.
Right. How do you think the new systems or new innovations would be designed to focus on a farmer?
Well, I think they need to consider the farmer's job in a nutshell, but I'll explain what I mean. So farmers are busy, busy people. If you know any of them, you know that they work really, really hard by definition, right? So they don't have a lot of time to, let's say, read all the latest research, look into all the latest products and technology. That's not their job, and they don't have time for it. So spending time gathering all that knowledge and distilling it for them is, first of all, very much appreciated. Second of all, they really can't afford taking on much risk. And that's where also research helps them, because if somebody spends their time and dime figuring out something, making mistakes, etc., and they can come to a farmer and say, hey, you should do this, it will help your operation. I've already tried it, I've already figured out how not to do it, there's no more risk for you, it's ready for you. That's also great. And then you also got to realize that it's a dangerous job sometimes too. A lot of the pesticides that, quite frankly, I've been asked to spray with no protection cause cancer and things like that. Yeah. And many tasks that these people undergo are back-breaking. There's a reason for that term. It breaks your back. It minimizes your lifespan. So when you design a system for them, try to make sure they can afford it, it meets their goals, the outcome that they're looking for, it's ergonomic, it's not going to injure them, nothing is unreasonably far away or heavy or long or what have you, and it keeps their options open. So that's another thing about markets these days is people are having to pivot quite rapidly and frequently. You know, it used to be you're a soybean grower, you're a sunflower grower, and you can grow the same thing for your 40-year career and die happy. But now the market really is volatile and changes, and people's tastes dictate what you should be growing. So we don't like to back growers into a purchase of a system that limits their options. Say, hey, you want to grow tomatoes? Here's a tomato system. If you ever change your mind, you got to throw it out and come to me for a different system. I don't think that's fair. No. So what you're looking at here as well can grow everything from microgreens to nursery plants to pots to flats to herbs and greens and tomatoes and cannabis and you name it. You can put giant pots with trees on here without having to switch out the basic equipment. And that's the reason that we based our system on that hardware.
So they're creating a more flexible way of taking care of all this.
Exactly.
Right, good. What about growers who are currently growing either in a field or in a CEA area, but in soil? What do you see as a risk of soil growing in these environments?
Yeah, soil, as much as we love it, I mean, it's life-sustaining, but it does pose a lot of risks because it's unpredictable and inconsistent. So there's a lot of horrible, horrible pathogens that come from soil. And I'm not talking about human pathogens right now. I mean, that is the case. If you use untreated compost, for example, people will die of E. coli and salmonella. But I'm talking about plant disease agents. They're rampant. And we've done a lot to destroy the good guys that usually keep them in check with our fungicides and herbicides and things like this. So soil is tricky. It, first of all, is not very efficient in the use of water and fertilizers, unless you're spending a lot of effort building good organic soil. And that's not something most large farmers really do. And there are ways to mitigate that, but it takes doing. You know, basically, you have to make sure that the fertility is actually adjusted. You have to make sure that the texture is adjusted. You have to make sure it's inoculated with good microbes and things like this. And if you do all that, you have excellent results. But the fact of the matter is, you can't tell everyone in the world to grow with soil, because some people are in the Emerald Triangle in California, some people are in Alaska, and some people are in the Sahara. It's really not fair to them to say, hey, you should be using soil. It's not practical everywhere, and that's where this kind of fills the gaps. Hydroponics as a root zone management tool that you guys, that's the industry you guys serve, and very well, as you said.
All right. All right. Is there any other projects that you're working on currently, or you see in the future that you're going to be heading to?
Yeah, there's quite a few. I'm not allowed to say very much about most of them, but
okay.
But the one in front of you
yes.
here is pretty exciting, because I feel like it's a very high impact project. And we're talking about developing nations, you know, that are deeply in debt, and that, well, some of these were relying on tourism. They got very much battered recently. So as part of an overall recovery plan, it's important that they take serious steps towards recovery and self-sufficiency. Relative to that, what we're doing in the US and Canada and Europe is a little bit more accessory. It's not as urgent, it's not as life-saving, it's a little bit more novel, it's a lot more fancy and flashy gadgets and innovations and technologies that are not always already directly impacting people's lives. But that is where the science frontier is. You know, that's where the big universities do most research and the biggest companies have the most funding. And so a lot of interesting things come out of that. And in that world, we're really just working on robotic automation, like eliminating the human-plant interaction, eliminating the need for you know, skilled growers and consultants, and taking a little bit off their plate by using artificial intelligence and multispectral imaging and drones and things like this. So that's what's going on there. But most of those projects don't grow food that they can really make money selling currently. They're ahead of themselves in a sense. It's necessary work, but it's not as basic and essential as, hey, we don't have food, so we import it and now we have food, versus we just need to kind of shift our food system around so that it's more sustainable.
Okay, so maybe touch base a little bit on the highly populated areas and where these grows can be implemented into a situation like that. Is it going downtown? Is it going in a restaurant? Is it on a rooftop? I mean, where do you see this going?
Oh, good point, good point. So I just have to say I'm a huge proponent of urban gardening. I think everybody living in urban environments should probably have some plants in their lives. If you ask me, those plants should be edible, and that's already happening. That's wonderful and heartwarming to see. What I have more issue with is the urban agriculture movement. The folks suggesting that our congested, polluted, expensive, saturated cities need to take on chicken and cow farms and vegetable farms and orchards and things like that. That is impractical. You spend an inordinate amount of money on real estate and utilities and things like this trying to do that, and your food often ends up overpriced because of it. It doesn't really create the maximum reach, and it exacerbates all those problems I mentioned. You know, you're increasing the carbon footprint there, even though you're reducing some transport. So I think the middle ground here is probably something that we should call suburban ag. There's cheaper real estate there. There's more space. It's right next to cities. Suburbs are right next to cities. They have the industrial areas. There's more warehouses available and empty lots and things like this. And the beauty of one of these greenhouses is you can put it on an abandoned parking lot that is virtually useless for anything else, traditional agriculture included. And I think that makes a lot more sense. Then you've reduced the food miles by 90-something% already. You are not competing for space and resources where it's already a problem. And I think that is going to do a lot to make the world go better. So back when we were talking about Ozark all seasons, that's the case. You know, they have several city centers within easy driving reach. They take care of all of them, and they are what you call out in the country.
Do you see any type of a footprint as far as what these guys grow and how far out they could reach? In other words, they're not like a field grown where they take it and they'll ship it hundreds of miles. I mean, do you see any type of something like that? Or is that anything you consider?
Yeah, these companies consider their regional markets. And if they want to expand to another region, they do that by opening a location there, not by shipping food there. So a good example of that is probably Gotham Greens. They're a company out of New York, and they successfully operated a few farms over there that, competitive compared to their competition, mostly on rooftops. And now they've expanded into Denver. Now, Denver has other hydroponic farms too, and you might ask yourself, like, why didn't any of them take that spot? Well, there's actually technical reasons why they have failed to grow and expand, and it's kind of unfortunate to see out-of-state companies come, but somebody had to do it. It's overdue. It should have happened decades ago, and it's better late than never.
Right. Yeah, it's interesting. I'm working with a guy that's in the Denver area that took on an old auto repair shop from the 50s and built a really, really boutique restaurant, grow, coffee house, whatnot. But to the point, his actual grow inside is 30 by 40 feet, and he does a vertical farming inside of that. So his actual grow is a little less than that because there's walking space around that. But he estimates with what he grows there that the footprint for the Denver or the front plain, Colorado, is about 1.8 to maybe 2 acres of land in that 1,200 square foot of what he's doing. So, I mean, imagine him going 2-story and he's at 4 acres, and 3 stories at 6 acres. So, I mean, it's there, it's coming. But he pretty much supplies everything that he does right there with that facility in his own restaurant. So it's pretty
great
cutting
model.
edge. It's a great model. It's wonderful. It's really good. Any other stories to tell us about some of these places you've been working with?
Well, my job does take me a lot of interesting places, and they do have very site-specific problems, and sometimes they're really out of my capabilities. But maybe I'll start with the beginning of my career after you met me, and I had to leave that job and start my own company. I say have to because I'm not a businessman, but that's what happened.
Right.
And the USAID sent me to Lebanon on an assignment as a greenhorn to consult with hydroponic farmers for free, of course. I had no experience. And my goodness, I grew up in Lebanon. I had no idea there were that many greenhouse farms and hydroponic farmers and things like this. Now they're having a very hard time, and it has to do with technical problems and political and economic problems. But that was a whole lot of fun. Those are some of my favorite weeks, where somebody drives me around to see dozens of farms, and you start to see certain patterns to make it very clear, what the priorities are,
right,
and what should happen first. And another highlight, I would say, is Jamaica. It's the mecca of cannabis, more or less. So anybody who's into that definitely makes it a point to go there. And yes, thank you, Tracy, for bringing that up. Hallelujah, cannabis is recently legalized there. So the Rastafarian community no longer has to be hounded and hunted like they have been for decades. They haven't been apologized to, but at least they get their sacramental right back. And the industry is nascent and going through some very interesting changes. You interested in talking about that, John? Jamaican cannabis?
Sure, absolutely. Yeah, absolutely.
All right. So first, we want to touch on the fact that people think Jamaican cannabis is good because they think the environment is conducive to growing it there. And it's literally the opposite. It's counterintuitive. The environment in the Caribbean, Jamaica included, is extremely harsh, actually. You have excessive light, excessive wind, excessive water, all the pests and diseases you can imagine, monkeys and rabbits and rats and thieves and so on and so forth. So it's extremely challenging, first of all. That is why Jamaican cannabis is so amazing, because what's survived are the champion genetics that can actually handle that. And I got to experience firsthand how taking those genetics and growing them in a controlled environment with less stress, they are incredible. They perform like nobody's business, to the point where you get results that these farmers and these breeders haven't even seen firsthand.
Wow.
And that's kind of endearing as well. When somebody gives you seeds, you give them back the product of their own genetics, and they've never seen it grown that way, so that just show them what the potential is. But anyways, back to technology and controlled environments. There's certain things that need to be adopted and certain things that can't. First of all, the existing greenhouses there, many of which are, simply put, the wrong type of greenhouse, do demonstrate the fact that cannabis production and even other plants can definitely benefit from some sort of CEA. So even when they're in soil, just having them partially shaded and shielded from the rain already significantly increases yields and qualities, because you don't have foliage getting wet, buds rotting and molding, and you don't have that basically infrared and UV burn that does stress out these plants and make them less efficient. It also destroys cannabinoids and things like that. So for a sustainable approach to cannabis production there, we're looking at basically low-tech, passive, climate-smart greenhouses. There's a lot of different microclimates. So you can't even say, hey, Jamaica, you need this. You got to go check the site first to make sure that you know exactly what's going to happen there. Certain sides get more rain, certain sides are more prone to hurricane damage, etc. But that natural aspiration we were talking about in the vegetable farm in Aruba, that is the right kind of greenhouse as a standard for this environment. You know, closing it up, trying to manage the environment that way, insulating, using humidity, it's just a losing battle. So you want to at least let hot air leave easily, at most pump it out actively. So that's number one. Number two is it seems like the light, in most cases, or at its peak, can be reduced by around 50%. And that's counterintuitive too, because in Europe they're saying, hey, 1% more light is 1% more production. Because in Europe that makes sense. In a rainstorm that makes sense. In Jamaica you already have way too much light for what you need. It's too much for people, plants, and animals. So that's great, it's a resource, but you actually want to control it. Cutting half of it out gives you better results than not doing that. Then you have the fact that despite this tropical environment with all these plants, there's not a whole lot of composting going on. There's abundant resources, but the methods haven't really been adopted. So there's a lot of potential there for organic practices of intentional composting and mulching to bring some of that fertility into the soil where it's very frequently washed away. So some soil building, some controlled environments, some very simple strategies like this, and you can already improve production of the amazing plants they have significantly. And then, inevitably, some high-tech approaches will be taken there as well. There's already people growing with LEDs indoor there because it's for the market that expects it to look like imported cannabis. But the possibilities are endless, still young, and it's only going up from here.
Right. Interesting. Do they combat the same problems that we do here with growing there? I mean, is it pests and disease and whatnot?
Yeah. All of them and more.
Right. And in your travels, it sounds like you've been pretty much around the world. Is that still the same everywhere? Is that universal? The pest disease, or what do you see? What do you find the biggest stumbling block that growers, that may be something that's kind of shared by all?
Well, there are some things in common, and usually it's integration of different systems. So again, these growers are usually not engineers, and engineers are not growers. That's what allows someone like me to have a job, more or less. And so you have to overcome the obstacles to growing something, which means everything that's going to affect your bottom line, everything that affects the yield and the quality. And in certain places, that is very much environmental extremes. I mean, just temperature and humidity, weather. In Canada, you've got kind of extreme summers and winters. And so your infrastructure has to be ready to handle all of that. And that makes it more expensive than something that is designed to handle one of those. Where you have more or less constant environments, like the equator, it's a different problem. You don't have that winter that beats the pests back. So the pressure is always on. It's maximally high, higher than anywhere else.
Right.
And you have an interesting thing like in Denver specifically, you got so much indoor agriculture going on, many of them using less than optimal protocols. And so you've got a lot of pests and pathogens that survive year-round inside people's facility, when normally nature would take care of that. But then anyone who's sharing personnel or plant matter, things like this, ends up being like STDs, for lack of a better term. Sorry.
Yeah, no, I get it. If you don't mind, I'd like to really quickly shift the focus to something that I'm passionate about, and that's pH and EC. I know in my travels that I go to facilities, or I talk with hobbyists or whatever. They'll spend a fortune getting the setup, getting their grow set up. they'll spend money on nutrients and lights. They'll spend a lot of money on finishing products, but they always seem to cheap out when it comes to pH and testing EC and temperature. And do you see that in your travels as well, or is it? I mean, how important? I'd like to focus a little bit on nutrient balance and pH. It's very, very important.
Well, that's the fundamentals, really, and yeah, they are far too often ignored or underestimated because people are excited and they get ahead of themselves, and it's not their fault, but it's our job to harp on the fact that first things first. And pH and EC are absolutely essential to be monitored pretty much as frequently as you can in a hydroponic system if you want to see it perform. So first, you're starting with a high quality fertilizer. There's a lot of options out there. There's a lot of great marketing, and many people will just learn the hard way by buying all of them and trying it. Well, I've done that, and most of them work okay for most things, and so you don't need to reinvent the wheel unless you have a good reason. But maybe I should touch on aquaponics real quick, because that's also very popular for good reason. It can be very sustainable. You got to remember that, first of all, fish feed costs more than fertilizer, number one. So it's never going to be cheaper than hydroponics. And later we'll talk about the end game for hydroponics, making hydroponics sustainable. But in aquaponics, you do have less control. People measure things like nitrate and nitrites, and of course pH, things like this, but there's limited things that you can add to make it right. You got to be very conscious of the fish health, the bacterial health, plant health. Mm-hmm. Each of those three that I mentioned have different optimum environments. You can train them over time, but it just really takes a lot of time to get it dialed in. And then if you change anything or hit pause, you got to start over. So it's not the most practical thing for most people at this point, and I think its reach will always be limited by that fact. So with hydroponics, you get what you give. I tell people tongue-in-cheek, you are God. If you don't provide it, it ain't there. Because in nature, you have so many insects and worms and microbes doing things for you that you can ignore and not even know about and be proud of yourself because you grew a tomato. But in hydroponics, if you didn't make it happen, it's not there. And you need to make sure that you have a good fertilizer, that you are adjusting constantly. So if you don't regulate your pH, obviously it doesn't matter how good the fertilizer is, it won't be available to your plants. If you let that get too far, it'll be irreparably damaged. You have to flush it out and start again. EC is the fertilizer concentration. Crops seem to be quite sensitive to that, and so you want to be aware of your ranges. You can actually mitigate the effects of some extreme environments using EC to a degree, raise it or lower it depending on just how much water is moving through the plant and how much fertilizer that delivers. But we have to admit to ourselves now real quick that hydroponic, water-soluble, mineral-based fertilizers are unsustainable. They're used because they're incredibly effective and efficient, but they're unsustainable. So as we use those now, we're looking for alternatives. And the alternative is not organics, plain and simple, all said and done. You don't want to put organic materials into your nutrient solution in a hydroponic system for several reasons. And a lot of them have particulates that can clog certain parts of the irrigation systems. Most of them, the point is that they're biologically active. So it's a slow release breaking down of organic matter to the inorganic compounds that plants mainly use. And that competes for oxygen. So you really don't want anything in there messing with your system or its performance, taking anything away from your plants. So in my opinion, that process should happen first. So the future of sustainable hydroponics is organic derived fertilizer. You receive it fully digested, let's say pasteurized and re-inoculated with good guys, and it's perfectly available to the plants and things like this. That's where I want to mention a company worth noting that has been working on this for years, and I think they made great progress. It's called Renewable, R-E-N-U-B-L-E, out of New York. And they're taking food waste and fish waste and finishing that process for you and sending you a bottle of the fertilizer, the type of fertilizer you'd expect to use that you can measure EC on accurately because it's dissolved, and that you can rest assured is sustainable. It's coming from waste streams, which is amazing. So that's the future there, and I think more companies will pick up on that, and we'll get some competition, localized production of all of this with localized, inputs of organic waste matter. That is the future of nutrient management in hydroponics. We need to be able to measure it. We don't want risk in there. We want to control everything with the same gadgets we currently have. So that's the way that that's going to happen.
So JC, what are your recommendations for someone looking to start up a new CEA business? I mean, what are some of the stumbling blocks? What are things they need to consider ensuring that their model of their business will be profitable? Because we know it is a fairly expensive business deal to start up. So what do you see? What are your recommendations on this?
Well, this part has nothing to do with horticulture, but start by selling your produce. Sounds weird, but make sure your produce is sold before you even decide how to grow. In other words, start with the market. Figure out what gives you a real business proposition. Then you have options on what structure to use or none, what systems to use or none, meaning soil, and weighing those costs and advantages and effects on the bottom line. And that all very much has to do with where you are and what you're growing. So most people really have a hard time tackling this multidisciplinary problem. There's consultants like me whose job it is to kind of hold your hand and make you aware of all the options, their pros and cons, so you can make a decision that falls within your budget. And you can also get specialists in each of those things to kind of help you understand more about it so that you can make informed decisions. But you want to make sure you're not spending money on technology that's not actually having a positive effect on the bottom line. That's just for show. That doesn't help your return on investment. You want to make sure that you're growing things you can make enough money on to make it worth your while and allow you to expand and hire the help you need, things like this. And always be conservative. That's another thing, is when we plan projects, I am at liberty of not being a systems salesman. You know, if I work for one of these hydroponic companies that is trying to sell their systems to buyers and investors, I would say, you're going to get the most plants out of this. It's amazing, and here's our numbers, and they're just kind of designed to impress. And then more than often, this first-time grower is not going to meet those expectations. They're going to be disappointed. They're going to blame it on you. So we try to go really conservative. In other words, virtually no matter how bad you screw this up, you will definitely get this. And then here's the potential if you do better. We want you to have realistic expectations, kind of look the worst case scenario in the face and say, I can live with that. Okay. So this is how we approach it. And when people are educated enough and aware of their options and have the right attitude, then they usually either decide not to do it, or if they do it, they're prepared for the worst and pleasantly surprised by the best.
So when you're hired to go into consult like that, do you kind of give them options, or do you design a system for them, or do you give them alternative options or styles to grow in?
I do.
Or do they usually have their own mind set up already?
Usually they're aware of the top advertisers. You know, the first thing that shows up on Google, the paid ad and things like that, they're aware of that. Right. They usually are not aware that they have many, many more options. And if they are, they don't know why they should care or what that even means. So there's definitely a lot of work to be had there. And I don't expect lay people to know all these things. It's several complicated aspects, the structure, the system, the lighting, the IPM. I mean, there's a lot of different companies involved. There's a lot of different research involved. And I'm that generalist that spends my time learning about them in order to serve people that don't have time to.
Right. There's a lot of companies out there, but there is one ECPH company. It's BlueLab. No. But we're going to go ahead and take some questions now. So if Tracy, you have some questions you'd like to shoot up here. Also, too, JC, go ahead and while we're waiting for something to come up, if you want to touch base on what you have immediately going. I know we talked about the future for you, but how much time are you going to spend in Barbados? And like you said, you're going to stay there until we get going, and then you're going to head on to the next opportunity?
Yeah, we go where we're needed, John. And I'm really excited about these projects in developing nations, let's call them, where, you know, this has been tried before and failed for reasons that we try to be completely aware of, you know. And I don't see it as a reason to stop trying because it's as needed as it was then, if not more so. It's more urgent now. So small efforts can have big impacts, especially in small countries.
Right.
You know, where the economy is such that one good farm can really make a dent in imports and the foreign exchange of money, you know, access to US dollars and things like this. And it can render tourism more sustainable as well. And it's actually, we're getting a lot of interest from kind of the resort sector because they want it as an added value proposition. And I'm really happy about that. In other words, big companies with a lot of power have power. They have the power to destroy and they have the power to turn things around. And I'm seeing smart choices made recently in terms of like capitalizing on the PR benefit of saying the food we feed you at this 5-star resort comes from here. You employ a local, you can go see it, touch it, feel it, you know that it's clean. It's a part of the offerings.
Or even like a grocery store growing their own produce and whatnot. It's a great concept. It's a great concept. All right. Well, I think I'd like to thank you, JC, for joining us today. It's very informative, and I learned a lot, and it's very interesting. So I'm going to go ahead and get ready to close this hour out. I want to thank everybody. As we close the hour, appreciate your time with us. Thought-provoking conversation today. JC, that was great, and I appreciate all you did for us on the hydroponic industry and the future of it. I'd like to thank the audience this time. The audience will receive an email with additional resources and a link to today's recording if they want to watch it. And I invite you to visit us online to learn more about us at BlueLab.com, and also go to our blog, The Art of Growing. So with that, I'm going to go ahead and close this hour out. And JC, let's stay in touch. I really enjoyed this. It was a lot of fun.
Okay, thank you everybody for attending. I hope you learned something.
Okay, we did. I'm sure we did. Thank you very much, and have a great day. Talk to you soon.
You too.
Bye-bye.
Cheers.
Bye-bye.